squared, 0. 1 squared is
4.
1 squared?
Wait, no, it's 1.
And then 2 squared is 4. Okay, now when you put in your calculator, you got to be careful. You would put a negative 1 squared, or negative 1 times negative 1, which is positive 1. Negative 2 times negative 2 is positive 4. All we're doing is we're taking these numbers and we're plugging into here if you were asking where that's coming from. So let's go ahead and plot that. 0, 0, 1, 1, 2 up 4, negative 1, 1, negative 2 up 4. So it looks just like what we did last chapter. Again, the only reason why we're doing this is so that we can see the difference between what we talked about last chapter and what we're going to focus on this chapter. What was the domain always? This is going from part 1, way back when. Yeah, all real numbers here. Ooh, that is not an infinity sign. There you go. Okay, range, be careful. What y value do we start at? 0, and I go up to where? Positive infinity. Very good. Yeah. Again, all stuff that you've seen before. Increase and decrease is usually where I do see a little bit of trouble, and it is a hard topic. You always want to talk about this x value, which is 0. So x is 0 here. Am I going to increase or decrease first? Decrease. Very good. So I'm decreasing from negative infinity to what x value? 0. Very good. Negative infinity to 0. Which then it reverses for the increase. So 0 to positive infinity would be the opposite. Okay, so going back here. Now, what is both the x and the y intercept in this case? 0, 0. Okay, so just kind of talking again about what we learned about in chapter 4, part 1. And we will now talk about cubics in a second once everyone's got this down. Yeah. You've been talking about quadratics for way too long. I'm excited for you guys to get out of it because quadratics are there's just really long. It's a lot going on for quadratics. All right, cubic. Now there's this new function that you haven't seen before. I don't think you have. You might have maybe took a glance at it, maybe in random delta math stuff from last year, but I have not given you anything cubic. When you plug in 0, you get 0. 0 cubed is 0. When you plug in 1 cubed, you get 1. 2 cubed. What's 2 times 2 times 2? Be careful.
Negative 8. 60.
Oh, up here, yes.
8.
8. 2 times 2 is 4. 4 times 2 is 8. Good.
Oh, there's the first one.
You're okay.
I know the second one too.
And it's negative 1, yeah. Because negative 1 cubed is really negative 1 times negative 1 times negative 1, which is negative 1. Okay, here we go. 0, 0, negative 1, negative 1, negative 2, down 8, 1, up 1, 2, up 8. And it kind of looks like a little snake looking thing. This is called a cubic function. So I'll leave that up there to make sure you get that. So it kind of looks like a little snake going on here. What's up? No. Now, again, a lot of people tend to really like cubics because the range isn't restricted, like how the quadratic is. The domain, is it forever going to go to the left eventually and forever to the right eventually? Yeah, so it's all real numbers. Now, what about the range? Is it going to forever go down and up now? Yeah, so it's all real numbers. I like cubics already. Increase. Now, let's talk about this. Watch. You don't have to write this down, but watch. This green marker. Tell me if it ever stops increasing. No. So if it's always increasing, what's the interval? Yeah, all real numbers. Negative infinity. That means it's always increasing because it's never decreasing. I'll put a little dash there. Now, tomorrow and the next day, you're going to see something that looks like this. Don't write it down. And there will be decreasing going on. But in this case, there will not be. They both have an x and y intercept at 0, 0.
That's all zeros.
Yep. Okay, so then again, the reason why we just did that is just to compare the two different graphs you're going to be working with. So again, this was from last chapter. Now this is the new thing that you're going to be working the most with this chapter. Okay, but a lot of the same stuff. You're going to do transformations again, like left 1, up 4, that kind of stuff, but now with cubics. Okay, so it all kind of goes together here. All right, so something that's really important when we do this chapter is that you know what the degree is and you know what the leading coefficient is when you know those terms, those vocab words. So the degree is just the largest exponent you see. So when you look at something like what we just saw, x cubed, 3 would be our degree because 3 is the largest exponent on that function. And the leading coefficient is the number that's in front of that. Okay, so it's the number that's all the way out in front when you're in standard form. And we worked with standard form a little bit yesterday. I know a lot of this is just definitions and it's boring.
Yesterday.
Sorry, last chapter. You know what I meant. Do you? I hope so. Okay, so let's talk about that. You have an exponent of 3, an exponent of 2, 1, and 0. What's the largest? What was it?
Wait, like the largest?
It would be the 3. The largest exponent is 3, so that's our degree. We have a degree of 3 is what that's called. Now, the leading coefficient is always the number that's like attached to that. So what number is out here in front? A 1. That's it. But it's going to be super important that you understand that, not really today, but more in a couple days, what the leading coefficient and the degree is. All right, again, here's 2, here's 1, here's 4, here's 3. What's the degree? Good, 4. And then what's the number that's in front of that one? 9. So that's going to be your leading coefficient. Because technically when you rewrite this in standard form, you would put that 9 all the way out in front. Go ahead and flip when you're ready. All right. There is something called the fundamental theorem of algebra, which we talked about last chapter, but it's not required that you remember what that is. But all it's saying is that if you have a cubic function, which looks like that, you should have 3 zeros because your degree is 3. Okay? If you don't have 3 zeros, it's called something called multiplicity. Again, not super crucial that you know that term, but multiplicity just means that that 0 happens technically 3 times in this situation. So it's when how many times a particular number is a 0 for a given polynomial function. Right? And I'll explain that more when we get to it below. So again, just to make sure that you are understanding what function we're talking about, a cubic function is a function that can be written as the following. Now, as you're writing this down, I'll kind of talk. Last chapter, if I were to cover this up, that's what we did. If I take it away, that's now what we're doing. So it's the same thing as last chapter, but I'm just adding one more to it. That's all. Kind of like, okay, same as last chapter. It's the same, just one extra factor. So remember, does anyone remember what a 0 is actually representing on the graph? The solution, which is also what on the graph? Like if I were to, what is that? The x-intercept. Good. So remember when you guys were solving on the test last week or just in general on last chapter, you were solving for the zeros, like x equals 5, x equals 4. Those are technically your x-intercepts. You can use that word interchangeably. So the 0 is like what you're solving for. The x-intercept is actually what it is. So what is that y value that you always get when you have an x-intercept? Like a number, comma, what? What would go there in an x-intercept? 0. Very good. Okay, just kind of getting your brain to open up a little bit. I know this is not the funnest thing in the world. We're just talking right now. We're exploring. Okay. Recall that when we're using x-intercepts or we're talking about zeros, a quadratic can be written in intercept form. So looking at this, you did this last chapter. This is quadratic. What is the 0 of this? What's the solution? X equals what? 4. And then what's the other one? Good. Now, again, zeros and intercepts mean the same thing. They're just written differently. So this would be 4, 0 and -9, 0. So if I asked you for the zeros, you wouldn't have to put it in ordered pairs. If I asked you for the intercepts, you would. That's the only difference. Let's do it again. Now we're in cubic. This is quadratic. This is cubic. There's 3 now. What's this guy? What about the next one? And the other one? 3 again. So this is what I was talking about earlier when I said multiplicity, is when there's a 0 that happens twice. That would technically have what's called a multiplicity of 2. Again, it's not super important that you remember that, but if you ever see that terminology, multiplicity of 2, it means that there's 2 zeros that happen at the same spot. Okay, so the x-intercepts would be at -5, 0, and it would be at 3, 0, and I'm going to write this down for you in case you would like to remember. It has a multiplicity of 2. And I'll try to show you what that means. You don't have to draw this in. You would have an x-intercept here, and you would have one here, and it would look something like this. If you see that 3, there's 3. You see how it has like a minimum right there, right on that x-axis? That's what it means to have a multiplicity of 2. It like comes and bounces back up off of the x-intercept. Okay. Again, we're not going to go into super detail about that, but it's nice to have in the back of your head when I say these things that you kind of know what I'm talking about. Okay. Now we're going to do the reverse. Okay, we have a cubic function. All these are supposed to be cubic, so it's supposed to have a degree of 3. So let's go ahead and set ourselves up. This guy has 3 zeros. 1, 2, 3. So I'm going to set it up. 1, 2, 3. X minus blank, x minus blank, x minus blank. Because remember, that's intercept form from way back when. Well, when I take this -1 and I plug it in, what happens to the sign? It changes to positive. When I take that 3 and plug it in, you just put it in there. Take that 4. Plug it in, and we're done. That's intercept form. Again, last chapter, we only had 2. Now we have 3. All right, this guy. We have 1, 0, so I'm going to write that down. X minus blank. When I plug in 2, you just plug in 2. Nothing really happens. But remember, we wanted a cubic function, so we have to make sure that there's a power of 3 there in order to represent its cubic. That's all. That would technically be a multiplicity of 3. That means that 0 would happen 3 times. And that's kind of like the one on the first page. If I go back really quickly to this first page, this guy, this multiplicity, that 0, has a multiplicity of 3. It only crosses once, okay, when it's supposed to have 3. Again, not super crucial that you understand that vocabulary. We're not going to do the model one, because I want to make sure that we're going to get the actual topic, which is coming on the next page. If we have time in the future, we might come back to this. So go ahead and flip to the next page when you're ready. I'll keep that up there if you were still working on it. Here's where you might need that calculator. Lots. If you are good at multiplying or you're good at typing it into your calculator, okay, then you're going to be okay here. If you like distributing, like first, outer, inner, last, or just distributing in, that's kind of what we're doing today. You just have to take your time, you have to breathe, and you have to be organized, please. Okay? Here we go. So again, something that you've done in the past. You've done those 2. Now I'm throwing one more at you. That's all. I'm throwing one more at you, which I know can be hard, but this is math 3 now. You've now approached math 3. Okay, last chapter was not math 3. Woo! Almost just lost the desk. Okay, so the very first step is we have to distribute that -2x into both of the first 2 in the first group here. So -2x times x squared gets me what? -2 times 1 is?
-2x to the third.
Thank you. Let me explain that. What you're doing, put a 1 here if you need to. You're doing -2 times 1, gives you -2. X times x squared, you're really adding exponents. So 2 plus 1 gives you 3. Or I have 2 x's and I have 1 more, which now makes 3. Whichever one you like. Okay, do it again. -2x times a -6 gets you positive 12. How many x's? Just x. Good. Here's how you know that. Look, this guy only had 1. This guy has none. So just 1. Okay? Now I'm going to bring this guy down. Very good. And now you're back to something that you've seen before where you do the first, outer, inner, last. The hardest part about this, in my opinion, is staying organized and working with the variables. Sometimes people get stuck on those variables. Here we go. Let's take it slow. Okay. This guy is going to come first. Negative 2x cubed times x gets me negative 2x to what power? 4. Very good. Remember, you're adding exponents. Here's 3. Here's 1. It gives me 4. Okay? Do it one more time with this guy. Negative 2x cubed times a positive 5.
Negative 10x. I don't know. Cubed.
Very good. Negative 10x cubed. That guy's done. Now remember, when you're doing distributing, you're taking one piece, multiplying it to everything over here. Then we're going to take the other piece and do the same thing. So that guy's done. You can cross him out if you want to. Some people do that. I've done that in high school where I was like, okay, I'm done with this guy. I'm going to just cross him out. Don't do it on your notes because I want you to forget which part you did. But all right, this guy now. Positive 12x times just x gets me positive 12x. Very good, to the second power. You can say x squared or x to the second power. You can say, because usually people don't know what 4 is, so sometimes it's nice to just say x to the 4th power. All right, one more. 12x times a positive 5 gets me, think of a clock. Good. Oopsies. Now let's talk about this. Can I combine anything? This guy's an x, it's an x squared, it's an x cubed, x fourth. Is anything the same? No, we're done.
That's it.
It's just a lot of multiplying. You gotta take your time. If you like colors, bring colored pens from now on so we can color code with me. I do want to show you something, a way for you to always check your answers. This is going to be super important and helpful if you get something like this on the SAT and or even like a JGC placement test where there's like multiple choice. There's a way to do it without doing any work. And I wanted to show you that in case that happens. Usually on one of those tests, it'll say like, find the equation that's equivalent to this guy. Well, you just did that. You just made it equivalent to this. They should be the same. And I want to prove to you with a calculator how you can actually see if you did it right. Again, and if you're given multiple choice, how you would do it, if it'll work for me. You will go to y equals. You want to follow along with me. Okay, here we go. Clear it out. Clear out what you have. Here we go. You want to type in the original problem that was on the test or whatever you're doing, homework assignment. So I'm going to type in negative 2x parentheses x squared minus 6, close it up, parentheses x plus 5. Again, a really great tool in the future if you get stuck and it says, hey, find the equivalent one. You can type all these in. Now type in your answer. So I'm going to type in what we got, negative 2x to the power of 4. You have to press the caret and the 4 button, and then press the right button to get over. All right, do it again, minus 10x to the power of 3. You press the little arrow, and then you press 4, and then you press to the right so that you can get out of it. So I'll do it again with this guy. So plus 12x to the power of 2. You press a little arrow up. And then you want to put in plus 60x. Okay. Again, if you get really good at using this calculator, it can really help you out on certain tests if you want to do well on those tests. Okay. Give you another second to get that going. Please let me know if you're having trouble putting that in. Now watch. Okay, I want you to watch for a second. I'm going to press graph and see what happens. Okay, so here's this blue thing that's going to come. There it is. It looks kind of crazy, but it doesn't really matter. As long as this red one, look at that. It's the exact same line. Okay, that's how you know you did it right. I want to prove something to you. Even if I just change one thing, okay, I'm just going to delete this negative that's there. Watch what happens. It's not the same. It kind of looks the same, but it's not. So here's the blue one. And here comes this red one. It's really close. See, there's a gap there, a gap there. Like it's not the same exact equation. Okay, so that's how you can tell if you did it right. It's kind of cool. Again, a great way to use technology for yourself. All right, let's do it again. Let me see. There you go. Here's the first one. So you have to kind of watch it. And then as long as it doesn't change, and when this little thing is done, you can tell. So let's see how it's done, and nothing was different. So it's good.
Knowledge of one day.
What's that?
Between two essay, and then.
Okay, so this one is just a tad bit harder, and I want to make sure that we do it together. Okay, so we got one more together, and then you got one more on your own. So this guy, just like when we put 5 squared is 5 times 5, x plus 1 squared is x plus 1 times x plus 1. We want to make sure that we rewrite that to represent the equivalent statement. You can just rewrite this guy too. So you're just rewriting. This guy is x plus 1 times x plus 1. Please, again, take your time and do one at a time. So I'm going to cover this guy up for a second, and we're going to just do that piece of it. Lots of just multiplying going on here. All right. Hold on. Make sure everyone's ready to go. All right. X times x in red is x to what power? Second. Good. X times 1 is just 1x. Are we okay there?
Yeah.
That guy's done. Are you sure? Are you good? Okay. So again, some people like to cross them out as they go because you have to get through all of them. 1 times x gets me 1x. And then 1 times 1 gets me,
2x.
careful. 1 times 1? 1 times 1?
Just one.
Just 1. Thank you. Okay. Now, you just did that whole group. They're together. This guy is still just chilling off to the side until we've completed the left group over here. Now, you could go and do this one like this. It will take you a long time. You should probably combine like terms if you can. What is 1x plus 1x? 2. Careful. Just 2x. If I have 1 apple and I have another apple, I have 2 apples, not 2 apples squared. Okay, so be careful with that. Bring down the plus 1. Bring down the x squared. Put it in a group. And again, this guy's just chilling, coming on down with it. All right. I'm going to make sure everyone's ready to go before I actually continue this one. Again, if you're okay with multiplying or even just typing in your calculator, it's not that bad. You gotta know what to do is the biggest thing. All right. So I'm going to explain it while some of you are writing. You're going to take each one of these 3 pieces and make sure that you multiply it to both pieces over here. So it's like you're doing 2 multiplications for each piece. So let's try that. So I'm going to do x squared all the way to here. What's x squared times x? X to the 3rd power. Good. X squared times -4. Very good. Now, again, this is where I like to cross things out. You don't have to do it in your notes, but like I bet, okay, that guy's done. I got him. I took him and I multiplied him to both. He's done. Okay, let's do it again. I have now 2x times x, which gets me 2x times x gets me 2x. Good. 2x times -4. -8. What? Good. All right, that guy's done. The 2x is done. Now I got one more. That's why I'm saying you take each piece and multiply it to both. I know it's a lot. Okay, but you can do it. You're fully capable. I know you are. All right, 1 times x gets me. Good. And then 1 times -4 minus 4. So I know it's a lot of like scribbles, but that guy is done now. We finished all of it. We just have one more step. It's not that bad. You can do it. If you guys were really good at factoring, this is nothing compared to factoring. Yes. Combine like terms. So I have these guys are the same in yellow. These guys are the same in green. So I have x cubed. What is -4 plus 2? -4 plus 2. -2. Bring down the x squared. The x squared's not changing. You keep it. Same thing. -8 plus 1. Negative 7x, bring down the 4, and you finished. I know it's a lot, but I know you can, there is no shortcut, I swear. Okay, but it's not like I'm going to be assigning you 10 of these. I'm giving you 4. It's not a lot. Okay, before you get your homework, I want to make sure that you are understanding this. So please do letter C. Okay, it's just like letter A. Take your time, call me over. Once you finish, I will give you your homework. So I'll leave this one up here for you. X times x, which gets you x squared. X times 2 gets you 2x. They're still a group, like they become its own group. Bring down the x minus 3. Now, take the first term, I'm going to underline this guy in red. He needs to be multiplied to both of them. So you would get x cubed minus 3x squared. That guy's done. Then I take this guy in green and I multiply him to both of them. And I would get 2x squared minus 6x. Now, you're almost done. These guys would combine together. And you would get a negative 1x squared minus 6x. Now, I do want to explain some things on the homework to make sure that you know how to do it. You only have 4. You can finish before you leave. Okay. Oh my eye.
That's not no Asian.
Okay. Number 1 is like number 1 in the notes. Number 2 is like B in the notes. So number 2, I already did half the steps for you. So if you look at number 2 on your homework, you're starting already from right here. Like we did all of this in your notes, but you're starting from right here on your homework. So I'm doing half the work for you. Again, in your notes, we did all of this work to get to here. On your homework, I already got you there. You just take it from there on.